Assalamu alaikum everyone, this is Fahlan Sari and I'm here to help you conquer chemistry. In this video we will be looking at Avogadro's law. And no, I'm not talking about Avogadro's constant. We already talked about that in a previous video which you should watch before we go to Avogadro's law. So Avogadro's law states that 1 mole of any gas occupies the same volume at the same temperature and pressure. So for example, at RTP, which is room temperature and pressure, 1 mole of any gas occupies a volume of 24 cubic decimeters. So room temperature and pressure, this basically means a temperature of 25 degrees Celsius and a pressure of 1 atmosphere. And a volume of 24 cubic decimeters, this unit may look funny to you, but this unit has a more common name, which is the liter. So 24 cubic decimeters is basically the same as 24 liters. So for example, let's say I have 2 balloons. One balloon is full of helium, while the other balloon is full of sulfur hexafluoride, which is SF6, right? So this balloon of helium at the same conditions, let's say RTP, 1 mole of helium would occupy 24 cubic decimeters or 24 liters, and 1 mole of sulfur hexafluoride under the same conditions would also occupy 24 cubic decimeters. But don't be fooled. Just because they have the same volume and the same number of moles does not mean they have the same mass. 1 mole of helium actually weighs just 4 grams, whereas 1 mole of sulfur hexafluoride weighs 146.1 grams. So the balloon on the right, even though it has the same volume, the same number of moles of a gas, it is much heavier because of the gas that it does contain, right? And by the way, just as a fun fact, if you inhale helium from the balloon on the left, you would get a voice that is squeaky like this. Whereas if you were to inhale sulfur hexafluoride from the balloon on the right, you would get a voice that is deep like this. Oh yeah. Anyway, so now that's out of the way, let's get to a question. So the equation for the complete combustion of ethene is shown. In case you don't know, this guy is ethene. Calculate the volume in cubic decimeters of carbon dioxide, which is this guy over here, formed in the complete combustion of 1 gram of ethene at room temperature and pressure. So for this question, we have step number 1. Using the data given, we will find the moles of ethene, right? We have the mass of ethene. We can find the moles of ethene. So the moles of ethene, C2H4, is basically going to be just mass of ethene over the MR. So the mass of ethene given is 1 gram, and the MR, which is the molar mass of ethene, which can be found by adding up the ARs of the elements in ethene, it's just 2 times 12 plus 4 times 1 for the 2 carbon atoms and the 4 hydrogen atoms. This calculation will give us 0.0357 moles of ethene. Now the next step is to find the moles of carbon dioxide. So we find the moles of carbon dioxide, which we are interested in. So if we were to take ratios, 1 mole of ethene will give you 2 moles of carbon dioxide. So 1:2. So if I were to place these in ratios, C2H4 ratio CO2 from the balanced equation is 1:2. So if I have 0.0357 moles of ethene, that is to a ratio X. And so I will cross multiply, and that will give me X is basically equal to 2 times 0.0357, and that will give me 0.0714 moles of carbon dioxide. Now the third step, and this here is the clincher, third step is to find the volume of CO2. So we find the volume of CO2. So for this, all we need to do is just look at a ratio again. So we know that 1 mole of CO2 at room temperature and pressure as given in the question is going to occupy 24 cubic decimeters. So if I have 0.0714 moles, that's going to occupy x cubic decimeters. So once again, I will cross multiply, and that results in x equals 0.0714 times 24. And that's going to give me 1.71 cubic decimeters. So this, ladies and gentlemen, is the answer to the question in 3 easy steps. It's going to be 1.71 cubic decimeters. Now for another question. It says over here 10 cubic centimeters of ethane is burned in 45 cubic centimeters of oxygen at a pressure of 101 kilopascals and a temperature of 200 degrees Celsius. So complete combustion takes place. What's the total volume of gas present when the reaction is complete, measured under the same conditions? So let's write the equation for this. Ethane is C2H6, which burns an oxygen, which is O2. Now complete combustion takes place, so the products of this reaction will be CO2, carbon dioxide, and H2O, which is water, right? Now balancing this equation, we have 2 carbon dioxides and 3 waters, balancing the number of carbons and hydrogens on both sides. And balancing the oxygens on both sides, we get 3.5 moles of O2. All right. Now we know that we have 10 cubic centimeters of ethane and 45 cubic centimeters of oxygen, right? Now we need to find out which of these two guys over here is the limiting reactant. In case you don't remember what limiting reactant is, you should watch my previous video. All right, so limiting reactant can easily be found using volumes. You don't really need to convert these volumes into moles and then work them out. You can directly work with volumes because Avogadro's law basically states that if you have 1 mole, it occupies 24 cubic decimeters at RTP. If you have 2 moles, you will have 24 times 2, which is 48. And so that basically means that moles of any gas is basically directly proportional to the volume of that gas, right? So keeping that in mind, a simple trick to solve this kind of question is to just get rid of the units of volume and just replace it by moles. It works either way. So let's say I have 10 moles of 10 moles of C2H6 and 45 moles of O2, then what? So we have this ratio over here of C2H6 to O2, which is 1:3.5, right? So if I have 1 mole of C2H6, that reacts with 3.5 moles of O2. Then if I have 10 moles of C2H6, then it should react with 35 moles of O2, right? But we have 45 moles, which is more moles than the 35 that we require. So our ethane over here, C2H6, this guy over here, is the limiting reactant. This will be entirely used up. So 10 moles of ethane react with 35 moles of O2, and so we're going to use ratios with ethane to the products. So 1 mole of ethane will give us 2 moles of CO2 and 3 moles of H2O. So this is 1:2 for CO2 and 1:3 for H2O. So if I have 10 moles of C2H6, that will give me twice that, which is 20 moles of CO2. And for water, it will be thrice that, which is 30 moles of H2O. Right. Now, the 45 moles of O2, only 35 moles reacted. So the moles of O2, the excess reactant remaining, this is the excess reactant. So the excess reactant that is remaining is 45, what we had originally, minus 35 that reacted. That gives me 10 moles of the excess reactant remaining. Now, all I'll do is, just get rid of moles and get back to the units of volume used earlier. So cubic centimeters, and cubic centimeters. So now I need to add up these volumes. I have 10 cubic centimeters of excess reactant, the oxygen remaining, 20 cubic centimeters of CO2, 30 cubic centimeters of H2O, which were produced from 10 cubic centimeters of ethane. So this will be 10 plus 20 plus 30. So this is 10 for O2 remaining, which was the excess reactant or ER. This is for CO2 and this is for H2O. And so this will give me 60 cubic centimeters of gas at the end. So this is option D. And before you get started on, wait, H2O is water, it's liquid, isn't it? Well, under the conditions given of 101 kilopascals, which is actually approximately 1 atmosphere, this is atmospheric pressure, the temperature 200 degrees Celsius. Under atmospheric pressure, water has a boiling point of 100 degrees Celsius. You have a temperature that's twice that. So obviously at this temperature and pressure, water would not be a liquid anymore. It would be steam. It would be a gas. And so we're treating it as a gas. And so we applied Avogadro's law as would be applied to any gas. All right. So Avogadro's law was applied in its true sense in this question right here. The number of moles of gas is directly proportional to the volume of a gas. All right, so if you like this video, do like, share, and subscribe to Conquer Chemistry for more videos. Inshallah, I will see you in the next video.